Welcome back to Advent of Code, starting on year 2017. So I already did one, so I'm just going to talk through the solution on this one. Day one, inverse captcha. The night before Christmas, one of Santa's elves calls you in a panic. The printer's broken. We can't print the naughty or nice list. By the time we make it to sub-basement 17, there are only a few minutes until midnight. We have a big problem, she says. There must be almost 50 bugs in the system, but nothing else can print the list. Stand in this square, quick. There's no time to explain. If you can convince them to pay you in stars, you'll be able to. She pulls a lever and the world goes blurry. When your eyes can focus again, everything seems a lot more pixelated than before. You must have you must have sent you inside the computer. You check the system clock, 25 milliseconds until midnight. With that much time, you should be able to collect all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day millisecond in the advents calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants you 1 star. Good luck. You're standing in a room with a digitization quarantine written in LEDs along one wall. The only door is locked, but it includes a small interface. Restricted areas, strictly no digitized users allowed. It goes on to explain that you may only leave by solving a captcha to prove you're not a human. Apparently, you only get 1 millisecond to solve the captcha. Too fast for a normal human, but it feels like hours to you. The captcha requires you to review a sequence of digits, your puzzle input, and find the sum of all digits that matches the next digit in the list. The list is circular, so the digit after the last digit is the first in the list again. For example, 1122 produces 3 because 11 and 22 are neighbors. 1111 produces 4 because they're all the same, all neighbors have the same value. 1, 2, 3, 4 is 0, all have different values, and this one produces 9. So solution here um, is I have my input, I map it to a list of digits, and I get a counter for my result. I go through each index. I have to figure out what the neighbor is. Usually it's I plus 1. So the index me is I, and I plus 1 is my neighbor. But if I'm the last one, then 0 is my neighbor. And it's circular. And then I can just check, is my input matching the input of the neighbor? If yes, I can add my input to the result list. So I get the first result, 1177. For part 2, you notice a progress bar that jumps to 50% completion. Apparently the door isn't yet satisfied, but it did admit a star as encouragement. The instructions change. Now, instead of considering the next digit, it wants you to consider the digit halfway around the circular list. That is, if your list contains 10 items, only include a digit in your sum. If the digit is 10 divided by 2 equals 5, steps forward, matches it. Fortunately, your list has an even number of elements. For example, 1, 2, 1, 2 produces 6 because 1 match and 2 and 2. 1, 2, 2, 1 produces 0, and so on. We can basically use the same algorithm. Found the result from 0 again, get the midpoint of the list, the size divided by 2. For uneven, you need plus 1, but for even, doesn't matter. Then I go through the indexes again. The only thing that's different is how I figure out what's my neighbor, where I just go I, myself, plus midpoint, modulo input size. So I always go, I offset by midpoint just to go jump half the list. And if I jump too far after the end of the list, start at the beginning again. Then I can check if I match my neighbor again and add the result to my counter. my input. And then I get R2, 1060. So that's it for day one. Thanks everyone. Enjoy the rest of your day.